Hello, the guest today is Beth Esponnette. She's class of 2010. She started a Series B startup in sustainable fashion. Hi, Beth. What is Unspun?
Hey, Tony. Awesome to be here. I've always admired what you do in your podcast. Unspun is a clothing technology company. We have invented a machine that does 3D weaving, and we basically looked at the clothing industry and said, why is it so broken? Why do we make clothes before people want clothing? And is there a way that we could redesign the way that we make clothing, the way that we introduce products into the world, and even change their life cycle to be more intentional and more in line with actually the natural world? And that's how 3D weaving came about. So Unspun makes 3D weaving machines and sells those.
Interesting. So it asks like the question of well, like why people need clothing in the first place.
That is a great question. Why do we need clothes? It's probably more sustainable to not have any clothing, right? I think that goes way, way back. And initially, I think it probably, back when we were wearing hides from animals, it was more of something that protected us from the elements and something that actually like helped us survive. Like if you look at different kind of species of humans back, I don't even know, in the hundreds of thousands of years ago range, the ones that hadn't invented needles and weren't able to build things close to the body and basically take a hide and kind of shape it to our bodies weren't able to survive the colder winters like Homo sapiens were. So I think there was actually an interesting kind of evolutionary advantage in us being smart enough to invent the needle and to be able to sew things and wear them that way. But also today, like it's even this ties back to evolution as well. It's also very much like a social thing. We say a lot with our clothing, we express ourselves, and there's a lot to say there. It's good and bad. It's great because we can be creative and express ourselves and feel like we are showing the world who we are. But it's also negative because that is the thing that has driven fast fashion, that has driven the reason that we sell, well, that the industry makes between 100 and 150 billion products a year. It's out of control at this point. And actually, a huge fraction of those, some say 30% of those, are never even sold. And that's a problem with actually just the way that inventory is kind of managed, the way that we predict what people are going to buy. But basically, it comes down to like the demand for new things because it is such a social capital for us. So there's both an element of like survival and needing to be warm and cold and kind of protect ourselves from the elements. There's also the social aspect of expressing ourselves, which includes just covering up covering up our body, right? So I think there's so many fascinating kind of perspectives to take on the clothing industry, whether it's psychological, anthropological, chemical, like from a chemistry standpoint, from a business standpoint, from a design standpoint. It's something that drove me actually to study it at Cornell in the first place.
So the needle, that's like an example of technology in making clothes. Well, what other technology is there in making good clothes?
Yeah, that's a great question. I actually went back, I think this was probably 6 years ago, and did kind of a survey of technology over the ages. And it has just become more and more automated, whether it's like being able to incorporate steam into it in the Industrial Revolution, or to now being able to take robotics into place. But over time, it moving from something that's extremely manual, where you're like shearing a sheep, or you're taking cotton balls out of cotton and hand twisting it, or using a spindle to twist those fibers into yarn, and then setting up like a floor, even like a table loom to make that fabric, and then taking those fabrics and stitching them together by hand. Like that was kind of the more primitive versions of it. Obviously, after the hide, right? The hide was like first, and then eventually we figured out that you could actually make things from fiber and that it would drape better and it was more breathable than a hide. To after those things, how can you make this a faster process and be able to produce at larger scale? And now that has been optimized, probably overly optimized, where we make way too much of it and it becomes very cheap to produce things, not just because they've been optimized, there for efficiency and that kind of aspect, but also because we've offshored that production. Like with globalization around the turn of the century, we decided that price was very important for us for clothing.
Hmm.
And making in the US was too expensive because it's so labor intensive that I think people assume, and I would understand this, like if I didn't have my background in this, I would probably assume the same thing. Like you look at a car and how that's produced now, because every component is like a solid piece. It can be manipulated in space generally easily. And so robotics can come together and kind of assemble parts or weld things together. And if the robot holds them, they know where all the XYZ coordinates are in space, and it can work that way. If you try to do the same thing with a piece of fabric, making that fabric into a garment, you lift it up and the drape is this crazy math equation that no one ever gets right. Because every time you lift it up, it's a different drape. And it's kind of been impossible, honestly, to nail that. And I know that was one of the last things that like Pixar really got was the understanding of like draping fiber, right? Draping hair, draping things that the properties change as you move them. That has been extremely hard to automate. And therefore, it hasn't been automated. It's still a hand done thing. So someone still sits at a sewing machine. They take the sleeve and they take the bodice and they put them together and they run it through the machine. It's very, very slow, but it still ends up being a cheap product to make because those people are not paid enough money. So I think that is something that's really driven down the price of clothing.
So the price of clothing has been dropping, but can't be fully automated because the robot can't see how the fabric drapes on the table.
The robots can see it, but I think you hit on a very two big challenges. One is computer vision. So much computer vision is necessary and manipulation. So the computer vision that's required is extremely advanced. Maybe we will get there soon, but what it takes to manipulate and put all those pieces together is way beyond what we've been able to achieve. If you've ever sewn a pair of jeans, or if any of your listeners have ever sewn a pair of jeans, you know that right at the fly, when you've got, you got the backing and another layer with the zipper, and then you have a middle piece and then the front, like you have in some places, there are 8 layers of fabric coming together with these crazy curves. It would be very impressive if a robot even got those pieces together, let alone sewed it in a quality way. That is one big reason why we came to the conclusion that we have with 3D weaving, where we said, this is kind of the process of getting from fiber to the final garment, but do we need all those steps? Like, why do we have to make a flat sheet of fabric, a kind of 2D, we call it like a 2D plane. And then in order to get to that 3-dimensional space, do we really need to like cut it up and then stitch it back together? Like, aren't joints problematic? Joints, and you think about like engineering, right? Like joints are the failure points. So why even introduce this in the first place? Plus that's extra waste, extra time and effort and steps, and therefore it costs more money. So let's just skip that whole fabric stage. Let's go straight from the yarn, which we view as like a one-dimensional, like a line, into the 3D. And you can weave almost like basket making. That's kind of like the easiest analogy I can think of is if you make a basket, no one's taking reeds and laying them flat and then like bending them and stitching them together. That's just not possible. You have to do it in a 3D coordinate from that reed to begin with. So let's do that with clothing. And that is much easier to automate because unlike a piece of fabric where like you pick up the fabric and it just kind of drapes and goes wherever it wants, and that's challenging for computer vision, challenging for manipulation. Instead, if you take a yarn, you can hold it on one end and then you can hold it on the other end. And it's just a line, you know where every coordinate in space. So if you're doing that with a lot of yarns, yeah, it can be complicated, but it is absolutely an equation that is possible to solve. So you can kind of
I've
manipulate that.
knitted before. Doesn't it flop around too? Or is it because it's like held at the place where it's knitting?
Yeah, really good question. Yeah, so because you could, if you designed a machine or however you're weaving it in a certain way, it could flop, or you could have pieces that are holding it in space. So on our particular machines, our 3D weaving machines, you start where yarns kind of feed into the bottom, and then they change direction and go up, and they happen to be in a circle. Like if you took a cross section, you'd see just lots of dots of the yarns going up, and those are held both by on one end on the creels we call them. They're like a bunch of these bobbins or cones really that have the yarn. So they're held over there and they're held taut, and then they feed through the system, and then they go up and they're held on various beams as it comes out. So because of that tension, it's being held in space and it doesn't flop. But that's a great question.
Huh, interesting.
Yeah, I know I do a lot of interpretive dancing when I try to explain what this is.
So is there like are there like limits on we can build using this physical mechanism? Or like could you make up, for example, with where the 8 pieces all come together with this?
Great question. So on our particular, like our focus machine right now, workwear, chinos, jeans, like that kind of weight of material is what we're going after. And so you can really do most pants. You really can't get to upper body. It doesn't go quite that big yet, but we will be doing that later. And then in terms of just like layers and thinking about complexity in the actual weave, our next machine actually incorporates that. And we've been prototyping off of it, but it's not our main focus this year. Next year it is, and I'm so excited for 2027 because of that. So that incorporates what's called jacquard. And jacquard weaving is very similar to actually computers. Jacquard weaving led to the computer, which is pretty cool. So jacquard means that every yarn, so those yarns that are like in the bottom and go up, those ones have to be lifted and lowered in order to create weaving. And if you lift and lower them in the same pattern, you're always going to have the same pattern throughout your product. If you individually control them and they're all on their own system, then you can have any pattern that you want. You can start to write your name into it. You can, to your example, you can start to build layers and actually have the fly pieces woven in separately. And the reason is that some of the warps can be sent to one layer of the product, some can be sent to another layer. The other wefts is what they're called. Those are like the orthogonal direction. Those can be manipulated and controlled in a way that they only are on one side or the other. So we're very excited for the jacquard because that adds even more complexity that reduces the number of finishing steps on this process.
Interesting. What are like the before and after? Like before this machine, like how did people do it by hand? Like weaving it by hand? Or like what was the before and the after like?
Yeah. So right now, I would say weaving, very automated, really great stuff. And there are a lot of different ways you can weave. So the kind of more basic way is with a shuttle. And a shuttle, I mean, it's basically like a little boat and it holds the yarn on it and it just gets passed back and forth as the yarns raise and lower. So you're controlling it that way. That's a little more basic, but now they have other kind of methods for sending weft yarn through a machine. And it's all possible because this is the legacy or traditional system where it's just a flat fabric and all you're doing is raising and lowering the yarns and passing something through so it gets intertwined. So another way of doing it is air jet, where like a puff of air actually sends the yarn through, or you could do water jet, the water sends it through. Another one's rapier, where you have like two arms on either side and one arm picks up the yarn, pulls it through, the other grabs it and pulls it to the other side. And then the yarn is laid that way and it just keeps going and it pushes it almost like someone's hands. So those are like methods that are used today in flat weaving. And flat weaving is pretty fast, but you end up with just a flat fabric. And you don't end up with a garment, you just have a flat fabric. In order to turn that flat fabric into a garment, you have to lay it out flat, put your patterns on it. So that could be actually like printed out patterns that you place on it. It could be taking a projection and cutting that way. It could be a laser cut. It could be CNC cut. There are a lot of different ways to cut it, but it's still all flat. And then you pick up those pattern pieces, and that's where someone sits at a sewing machine and manually sews those things together. So that's the biggest challenge, is what we call the CMT, the cut, make, trim, the cut and sew aspects of it. And so with 3D weaving, we're jumping over those. We're saying, let's make the fabric at the same time that we make like the full garment, because no, the fabric is not faster to make this way, but you're doing the whole process in one machine.
So like the algebraic equation is you got time saved like for each of the step. So the cut CMT, each step takes time and you're cutting out the human time, but the computer time increases.
The weaving part is pretty fast also. We've really just taken and you're weaving the material that would make the product as you're getting the form set up. So it's really reducing. It kind of depends on the product, but it's anywhere from like 30% to like 60 or 70% reduction in time.
Like human time. So like humans cause like so the time human time decreases.
Yes, exactly. In some ways, that's really good because then you can start to onshore production again because it's cost prohibitive to make here in the US. We're really targeting Europe and the US, where the industry has left. There's a really tiny bit left, but it's like 2% of what it was just 25 years
Yeah.
ago. And it's only propped up by the Berry Amendment, because in the US anyway, because the military and other government functions require that you make things in the US. Only thing propping this up, because you go to the factories and it's just hard to be efficient here. So if we can put our machines here in the US or over in Europe, then we feel like we can rekindle the industry.
Gotcha. That makes sense. And how about like material usage? Like before you had to cut and then trim it. That trimming part, you have a lot of wasted fabric. Like how much fabric could you save because of it?
Yeah, so right now we are making like the shaped tubes of the legs. So all we have to cut out is the rise. That's the part that joins the legs together. So if you're cutting that out, that could be up to 5%, but typically you have pockets in your pants. So those that actually ends up being cut from that rise shape. So we're anywhere from 1 to 3% cut waste compared to the industry of 10 to 15%. We feel like that's really good. And that's on our current generation of machine. As we incorporate more and more jacquard capabilities and incorporate more onto the machine, we'll reduce that amount even more.
Gotcha. You said the onshoring part, that's like it's hard to hire people in the US for that. Well, what other considerations are there when the person buys a machine?
Yeah, and I mean that is our business model. So they're basically thinking about not only like you said, how much am I saving direct, like we use FOB, like freight on board or free on board kind of numbers when we are talking with factories, and they're usually those are the things that they say to their customer, this is how much you have to pay per unit. And so we'll do one-to-one comparison. Here's what it would be for you traditionally to cut and sew it. Here's what it would be with us. And so that amount of savings is really helpful for them, obviously, and that increases their margins that they can get. And they might even be able to reduce the price that the FOB price that they give to their customers, who are the brands usually. But not always. They could just say, we're going to keep price, but we get to increase our margin. What's great for brands, because brands could just could just pay the same price, they're getting a faster turnaround because we've consolidated steps of the process. And the goal is to just make a more intentional process where you as a customer, like the end goal, and we can kind of work backwards from this, end goal is for an actual consumer, someone who's buying pants, to buy from a website, ideally get like a body scan or something that can allow it to be custom. That information feeds back to us. And because our machine is driven by software, driven by things that are very easy to change piece by piece, unlike a traditional process, then you could run a different pant for every customer that buys. That's our end goal. We're not there yet because it would cost, just like from a systems standpoint, it would probably be like $100 a pant, which is too much. But it's very much on the horizon for us. Like it's coming up soon, and we're excited to be talking to different customers, different manufacturers, different brands to figure out who should be the first and second brands to kind of launch this into the market with us. In the meantime, the value prop is more, this is a great replenishment model. Like we can really reduce your lead times. You don't have to guess, 9, 12, 18 months in advance what you're going to buy or what the customer is going to set to buy, right? Instead, we can really cut that down to weeks because we've consolidated the process and because we've brought it on shore. So I think that's the bigger thing that a manufacturer and that a brand is thinking about when they buy these machines. Like, how can we have a more intentional process and not create as much crap for the world?
That's so interesting. So, is there like a lot of pants that get made each year that don't get sold at all?
Yeah, not for us, but for the industry, it's really hard because of those supply chains and how they've been offshored and they've been optimized for price. So if you're optimizing for price, you're going to really go up in quantity, right? And also lead time, because if you're going up in quantity, you're also going to be extending your lead time a bit. So that's where 12 to 18 months becomes, honestly, 12 would be pretty quick. 18 months is pretty standard for a lot of these brands to be putting in orders and then expecting those to be in a store. And in the age, we're like way well beyond the internet. We're into social media, we're into AI at this point. Like the turnaround of trends, it makes no sense to guess 18 months ahead of time what people are going to be buying, because trends change on an almost daily basis at this point. So we need to create a system that can work better with what people are expecting.
How long does it take to make a pair of pants?
It's 8 minutes on the machine, and then it's like it's about 15 to 18 minutes for the full pant.
Wow, that's pretty quick then.
Yeah, yeah, yeah. Because we have to be. There's so much happening right now, and maybe not a good thing in the fashion and sustainability space. Like Allbirds just had to pivot and become an AI company. And we just saw yesterday, 2 days ago, Everlane got bought by Shein. Like there are some pretty challenging things happening in the sustainability space, especially in fashion. No one believes it. Consumers are not willing to pay for it. you really can't rely on sustainability to sell. We've always come at it like, yes, sustainability is what drove us to start this company. Like we wanted to make a better process, learn from nature with its growth and decay cycles, and yeah, just create the industry that we felt like should exist given the new technologies that have been invented since the sewing machine was invented in the 1830s. But even though we started on sustainability, we still have to consider the industry we're in and the world we're in, and it's so capitalist, and we need to make sure it's more efficient and more cost effective. And the way that we're honestly, it has come together well is that if you consolidate steps of the process, not only are you being more sustainable, but you're also saving money. So it's worked well in that regard. And I really hope that anyone in sustainability in the fashion industry or really just in the world can find those places where it makes more sense from a business standpoint and they don't have to talk about a green premium.
Earlier, you talked about like there's like clothing lets you survive in the cold and also makes like a social message as well. But like if it's made with your new machine, does it help with either of those, survival or the social?
So survival and social. Okay, I think I've never gotten this question. I really like it. Survival, it's lighter. The, these products are what I really like about them is like thinking about like from a purity standpoint, only making what you need to. And when you look, like watch nature, watch the biological world, how does it make things? There's no factory pumping out stuff and distributing it around the world. It's very localized, it's made as it's needed, and it's additive. Like you're growing in response to things in the world or as life forms evolve. Things are growing and then they're decaying, but they become other things. There's a lot of cycles there. And I think something that is really beautiful about this is it's also additive. So we are building the product from the ground up. And so you're building it and you can also break it down kind of the opposite direction. And that falls in line more. It's not like animals should be wearing these products or anything. It's not like these factories should exist in the Amazon, but is there a way that we can take inspiration from nature so that what we do on our planet aligns better with the planet we've been given and the reason that we exist and the reason we've thrived? So I see it not necessarily as like the product is going to help us more in the cold, but the way that we exist in the world will be more in harmony with nature if we kind of examine how we set up our systems and processes within the world we've been given.
That makes sense. And on the social message side, like how does it fit in? Like if like a famous designer designed the clothing, a lot more people want to buy it. Does it fit in with that workflow of like a famous designer? Are they able to create the design and feed it into your machine?
Yeah. So, yeah, I'm glad you're bringing it back to the social one too. Here, unlike with the traditional industry, which the goal there is price, like let's bring the cost down as much as possible and therefore pump out a lot of product. Here, we'd like to get to a place where it's possible to make things that are varied, that they fit each consumer in a more custom kind of way, whether it's custom fit or custom design. And allows them to that so speaks to a social aspect, right? Because then you can kind of express who you are and you're not buying the same pair of jeans that everyone else has. Like it's got a special twist to it. And maybe it's not so important that everyone has their own thing, but it actually would. There have been like studies that show that if you repair something or if you had your hand in making something or if it's special for you or if your friend, like someone who means something to you, gave you something, you're going to value it
Hmm.
more. And so if something is custom to you, no one else in the world has it, you're going to value that thing more. And I think we need to appreciate the things around us a little more because we've gotten so nonchalant and so unappreciative of the products that we're wearing. One, first of all, it makes us uh in some ways not appreciate our lives as much because it's just like you just take it for granted. Like, oh, I've just got this thing. Whereas if you really understand what goes on behind the scenes, if you will, then you will then you will, or the lack of seams, I guess, then you start to appreciate the beauty in life. And I feel like people obviously should extend that beyond just the clothing around you, extend that into the built environment and even the biological world. And I think that would be a really good thing. Plus if we value our clothing more, we will be willing to, spend more time investing, like saving money and investing in something that will last a lot longer, won't appreciate it, and we won't be making so much crap and throwing it away willy-nilly.
Makes sense. It's like it doesn't require a tailor anymore, right?
Yeah, but then I still love the idea of tailors, especially if you're going to like pass things around to different people in your life. But one thing that we have, I go back to like inspiration from nature again, but one thing that we've taken inspiration from is, I mentioned this before, the growth and decay process, like building up atoms and molecules into something and then breaking it down into its like constituent pieces or its like elemental or fundamental pieces. Here we view that like fundamental piece as yarn. Can you build up a product in yarn and then go backwards and put where you're unwinding or unspinning your product back onto a bobbin again and then can be reused. So in that sense, you're right. There might not be a need necessarily for a tailor if something kind of comes out to spec for you. Or you might decide that you've made it, but you want to change it, or people's bodies change, right? So there's always something there.
Interesting. Wait, so you can like unmake the clothing as well?
Yes, we are not anywhere at scale. We need to make sure that our machines are out in the world, and one of our goals is to decentralize manufacturing. Right now, most of clothing manufacturing, like if you look at your labels, really good chance, I don't know, 98% chance it's somewhere in Southeast Asia that you find on a label. And it's not like that those aren't great products or they're not doing a good job. It's just that it's centralized there. If we can start to kind of like watersheds or like fiber sheds, like create little local systems, then we can start to become just like have something where you could unwind and could create again. But right now with recycling or being able to like remake your product into something new, it's a really hard logistics question. Like, I don't even know how you collect all that stuff. And there have been a few documentaries that have come out recently that have shed some light on the challenges there of like collecting all these things and shredding them up. And I think because of the places in the world where a lot of this is being done, they want to do it in cheap places because it's a very labor intensive process to try to recycle these things. And recycle is the wrong word, but downcycle these things. And it ends up being that you have to go for places that are extremely, don't pay people well. And because they can't, like, it's just the part of the world, have very low regulation. And so people end up getting very sick from the fibers that are floating in the air and the chemicals involved. So I really hope that we can continue to find solutions for what we might do with the 100+ billion products that we make every year.
Yeah, that makes sense. Societal wise, like I have a wardrobe. I have like 3 of these t-shirts. A very good Cornell t-shirt. I got maybe another 10 or 12 other Cornell t-shirts. And then I have a couple Cornell jackets. So, like, what's a typical wardrobe of humans in the world? And how will the wardrobe change over time?
Ooh, I like this question too. I don't know the typical. I would say anywhere you probably have a little more willpower than most. I think most people would be buying in the hundreds of pieces. And so it sounds like you're in the tens of pieces, maybe 50 to 100 pieces total. Most people are going to be in the hundreds. Like 200 would be low, 200 to like 1,000. Yeah, it's a little crazy. I don't have an exact number because I have not surveyed people's wardrobes, but I have been in this industry enough to know that that's pretty normal and have seen sales from across brands, and you can kind of understand how that might be distributed. But then 30% of what is made doesn't get sold typically. So like if that's a brand, those brands have to figure out, how do we offboard these things? Burn them, trash them, sell them to another country, try to get them sold in another tier of the market. But then some of those decisions, like sending them to another country or having them sold in another tier of the market, is going to be damaging to their brand name. So a lot of the higher end brands and labels will end up burning or trashing, really burning so that there's no trace of it anymore.
Wow.
Right? Because if you just throw it in a landfill, someone could find that label and say, ooh, this luxury label, not so good. But it's actually worse to to burn it. So there's really no right answer to this. But yeah, so those are kind of the numbers that you would expect in someone's wardrobe, and how would it change over time? That's a really good question. I think that people will be able to curate their wardrobes a bit better. I'll give a plug for a another company, another startup that I am an angel investor at. So I'll fully disclose that I'm supportive of them. But they're called Alta, and it's a wardrobe app, and it's incredible because they not only will like it shows you what you have, it shows you what you haven't been wearing, it shows you what you've been getting a lot of use of. And then it will even dress you so you can see what works together or how you might show up at a party or an event or something. And so it's cool to be very intentional that way. And what I'm finding is that it's helping me to curate a little better. I'm like, oh, I don't wear that, and I don't think I'm going to be wearing it. But what can I hand it off to a friend or something? And what's hard about that right now is they're not good systems for the cycles of like, I want this new thing and I need to get rid of this old thing. It's just buying more stuff and getting rid of more crap. And there's not really a good place for it, except that resale is becoming bigger, which I super appreciate. But still, resale is challenging because if there's any little damage to it, they won't really accept it. So that needs to be really figured out with resale. So I think that over time, as we start to hopefully improve our recycling systems, if you want something new, that you figure out, I can take the material or the whatever from this piece that I have, and maybe it can become this other thing. So I think hopefully we can be more intentional and recognize that we only have one planet to work with and not the two or three that we're actually using.
What do animals do with their like fur? They don't they just have one set.
Yeah, so everything for them, because it came all from the biological world, it's just like us with our hair, right? Like our hair kind of regrows and falls out. Like for them, the fur will fall out and regrow. And it's a protein-based thing, right? So it's like it's just gonna fall out and then it's gonna get recycled into the ground or wherever it fell. And it just becomes part of this holistic system that we have versus what humans have done, where we have the geniuses that we are in some ways, very genius in some ways, like maybe not so thoughtful, have come up with new materials that are invincible to are almost invincible in some ways, like in practice are invincible against these cycles that have been going on for billions of years, right? Like before us, there was no trash. These cycles just continued forever and ever. And then we said, these are amazing resources. Let's take them and then make them into something new that is a completely different stream and I was going to say cycle, but it's just linear, that we've taken something that gets in the cycle and then we've changed the chemistry of it, where now it's immune to, the breakdown that you would have in the biological world. And I'm sure you've even spoken with some really smart people who are thinking about how do we break down plastics and other things that
Yeah,
humans have created, right? So there's a lot of hope, but we really haven't figured it out quite yet.
very interesting. So back to those like how you started a startup. How did you get started on this? How did you pick this as the problem to solve?
Yeah, I can tell you about what drove me to start this, and then I can talk about like the support systems that we got in place to get it off the ground, because I think they're both really important. So I studied clothing at Cornell. I loved it. I thought it was so cool how they basically took an industry and they said, how can we look at this industry from different facets? So, there were polymer science classes, anthropology and sociology classes, business classes, art classes, design classes, engineering classes, like all looking at one industry, which was super cool, very different from what you would see in other programs, and also really, really good for finding a very specific kind of job when I graduate. Maybe was too specific in some ways because I went actually more broad. I went broader once I graduated, studied design more generally in grad school, but I still loved like being able to take one thing and a focus and look at it from different angles. So once I graduated, I was confronted with the industry. Like I thought this thing that was creative, like builds confidence and was so beautiful and glamorous, and that I loved the functionality of it, and thinking about like how we wear this science and this art every day, but it gets overlooked. Went into the industry and was like, oh my gosh, I was a developer and I was a material researcher at a few different really cool outdoor clothing companies and outdoor gear companies. But my job became like, you get a bomb of materials, for your product, and you need to figure out how to chip away at all the costs. Or you get like a breakdown of here's what it took to put this product together. how can you like whittle down? And so I felt like I was driving down the person or the people at the bottom. Like, why are we squeezing them for pennies? Like, isn't there something else here? And as a material researcher, I also got to see or had to confront how much waste I was part of. Like putting in these orders that I was like, we don't even know if someone's going to buy this, but I guess we can make all this stuff. And I got really frustrated and I could sense that I didn't want to go to work every day, even though I loved this industry so much. And so that is something that drove me to ask the questions of like, why are we making all this stuff that people don't want? And that drove to the question like, what if we made products on demand as they're needed, instead of just cookie cutter overproduction? And that led to a lot of research and diving into how we make things today, which is something I had studied before, but still took like extra lenses to it and going through the motions and traveling around the world. And I was very lucky. So, like, after a few of those jobs and after working in a machine shop and traveling, I went back to grad school and I wanted to basically take this question on in grad school. I think a lot of my classmates went in with like a very open mind and wanted to learn everything and absorb. And I had a little bit of that, but mostly I was like, I just want to ask the question, how might we make on demand? Like, how might we build things more like nature makes them? And I just took my whole program from that perspective. And it was such a big motivator for me, but it also, maybe I missed out on some other things that way. Maybe I should do grad school again. But through that exploration, of a lot of very silly ideas, including like growing clothes from chia seeds in my garden, or like taking and pretending I was like a big human 3D printer and taking hot glue and like building dresses with it. Like there were a lot of really silly things that came out of it, but I think it was all a process of prototyping that I feel like we're gonna lose out on with AI. I'm very excited about AI in general, but so much of what started Unspun was a very physical prototyping process of exploring in the real world how we might make on demand. And that eventually led to 3D weaving. And I don't think AI would have taken that route or got to that kind of the same approach. And then I can tell you about, so that was some of what started the company. And then
The support systems.
yeah, yeah. So in grad school, it was awesome because I had kind of a safe space to try out a lot of these ideas. And I feel like everyone should just take wherever they are as a safe space, but it's hard to really do that. It's easy to say that. So I had a safe space where I could, yeah, test the ideas, see what it was like to motivate a team around these things, communicate, and eventually you start doing pitches, you start showing up at, venture capital groups. Our first money came from Highland Capital Partners with like a really tiny check just to see where things would go. And then we went to the National Science Foundation, got some money from them. Then we worked with the hardware accelerator called Hack, and they also were very supportive of us, especially from a like prototyping standpoint. We got to go to Shenzhen, China, and we spent almost half a year there in Huaqiang Bay area, like building our not the first prototype, but some of the first prototypes, some of the less embarrassing first prototypes. And yeah, really get it to a point where we could start talking to real people, I guess. Yeah, so that's sort of like where the funding started. And then once you show a little bit of traction, whether it's like with the brands as a customer or as direct to consumer as customer, then we could start talking to VCs and build it from there.
Gotcha. Interesting. Is it what's the typical path for a fashion technology company? Do you
Ooh.
usually try to sell to like the big brands first, or do you work with the smaller brands first? Do you make the machines yourself and sell it to a operator, or do you operate it yourself? What's the typical path for?
Honestly, I still think about this one a lot because I don't know that there's a right answer. The approach that we've generally taken over the last few years is that it takes a lot to convince the fashion industry that it needs to do something new, even though it's so stuck and broken. Like they know there's a problem. It's just hard to get out of that. They're like in this flywheel of just like things that are not working well. And so just starting from nothing and then trying to sell it to them, it's not really possible. You do need to build it out yourself and run through the motions and pretend you are them and say, look, like we're a brand, we're doing it, and look, you can do it too. And show them all of the pieces, not only that it's working, but it's financially makes a lot more sense and that customers would want it. So we actually started out as a direct to consumer brand and sold product. We did over 20,000 body scans and sold just as many pants to customers in the early days. And now we've become more and more B2B, which has been our plan over the years. Initially, we just want to go straight B2B, but realized that there was going to be a challenge with trust and like showing them that it's possible. So moving from direct to consumer to B2B directly to brands to show here, we can do this pilot run with you. And now we are signing with manufacturers, and manufacturers or like the factories are really our end customer. They're the ones that like we are directly selling to, and then they can take our machines, use them to sell to brands who then sell to a consumer. So there are a lot of different customers kind of in our cycle.
So the list of consumer stakeholders were like customer, the end wearer of the pants. Then there's a brand designer of the pants as well. There's a manufacturer of the pants.
Yeah, so
So
you
what are
have
the different steps?
you've got the brands. We can start with let's start with the factory. So the manufacturer makes the products, the brand buys from the manufacturer, and and then the consumer buys from the brand. So it goes factory to brand, brand to consumer.
Gotcha, gotcha.
Yeah, yeah, yeah.
Interesting. So a lot of brands don't manufacture themselves. So you have to get buy-in from all three, and then they put.
Exactly. Yeah. It used to be that, I don't know, like maybe before globalization, definitely like 100 years ago, but maybe not even that long ago, a lot of brands built their reputation on like the quality of their manufacturing. But as we offshored more and more production, it became just standard. It's like so standard for brands to buy from other factories. So they don't own their own factories typically. Yeah, I think like Carhartt has one. There are a few that have one or two, but it's pretty rare.
So the manufacturer would be the one that buys the machine, but the brand has to know how to design for the machine so that they could feed your design into it. So like
Yeah,
two
and
different stakeholders.
yeah, but we really are very supportive. We end up because of our software does so much of the process, we can just be there to kind of hold hands through the process of the software and run it that way. So it's actually there are a few different groups involved, but that's pretty normal, I would say.
Huh, makes sense. And for the closing question, I always ask the guest, well, what's the kindest thing anyone has ever done for you?
Wow, the kindest thing. What can we just say like a kind thing? Because I don't know that I'm gonna think of the kindest thing. I think about my friends bringing me a pizza after my first baby was born. They like walked a couple miles with like a pizza to my delivery room, and it was definitely something where like they all had a lot of things happening in their lives, but they just dropped all of it to make sure that I was well fed because they knew how bad hospital food was. So that's just one thing that comes to mind, but there are so many there are so many great things that people have done.